All right, so today we've continued with our looking at probability, and that moved into permutations, which we were looking at the past 2 days, and then today we looked at combinations. Now, combinations, when we use that word, is a little different. In math speaking, when we think of combinations, it means order doesn't matter. In permutations, it means the order definitely does matter. Okay, so to give you an example of what this might look like is, let's say, for example, you have 4 kids. We're going to give them really creative names of A, B, C, and D. Okay, just to make things easier. So one kid's named A, one kid's named B, C, and D. And if we wanted to make groups of 2, we want to say how many groups of 2. Now, one way I could do this is simply by listing all of them. Okay, so I could have, for instance, AB, AC, and AD. I could do BA, BC, and BD. I could have CA, CB, and CD, and then finally DA, DB, and DC. Those are my groupings of 2 kids. Now, if we look at this, this is not a permutation problem. The difference here is that we have 4 kids, but these groups of 2, these are this A and B is the same thing as B and A. Order doesn't really matter in this situation. So this is not a permutation problem because A and B is the same as BA. So I could cross out BA. We have A and C, that's the same thing as CA. A and D, that's the same thing as DA. Could keep going. I could see B and C is the same thing as CB. We could see that let's see, B and D is the same thing as DB. And then C and D is the same thing as DC. So I've crossed out all of the ones that are doubles. And we see we're left with 1, 2, 3, 4, 5, 6. We could actually have 6 unique groups of 2. And that's a combination problem. If we were looking at a permutation, right, we would have groups of 2. So we would start with 4 kids to choose for the first person, and then times 3, which would give us 12. However, right here, we're seeing there's actually really 6. So this is not a permutation. Okay, because order doesn't matter here. So there's a couple ways to figure this out then when we're looking at an actual math problem. One is that we could simply say, okay, well, I'm going to draw or list out all of my options and I'll cross out the doubles. That's going to take a really long time, and when we start working with bigger numbers, it just isn't reasonable. So we're going to look at some steps for solving combinations. This is just the way that I'm going to say them. Hopefully this makes sense. I'm not really getting into why you can do this right now. I'm just more getting into like what you would do to solve this. So the first step you're going to do is you're going to find the permutation. So it would be the same thing as we would have over here. Okay, the second, and I'll go over these a little bit more in depth. The second step is going to be then to find the factorial of the smaller set. Remember, factorial is that exclamation point that just means we're multiplying it by subtracting 1 and multiplying it down. So 4 factorial is 4 times 3 times 2 times 1. Okay, right, 4 times 3 times 2 times 1. 2 factorial will just be 2 times 1, and so on. And then finally, there's some division that's going to take place. So you start by solving these just like you would do with a permutation. So let's see, if we were doing this, find the permutations. We had, how many groups of 2 could we make? We had 4 kids. Okay, so to do that, we would simply just do 4 times 3. Okay, we had 4 people to choose for the first one, A, B, C, or D. Once we've chosen one of those, we're left with 3 people left, so we would have 4 times 3. So that would say there are 12. So if order mattered and who was first and second in line, something like that, then 12 would be our answer. There's 12 different ways we could set this up, 12 permutations. But right now, order doesn't matter because I'm just doing groupings. So what I'm going to do is I'm going to find the factorial of the smaller set. That's the same thing as how many you chose. Now, I chose 2 for my groupings. Okay, so I just made 2. I just was working with 2 numbers here. So I would simply find 2 factorial, which is the same thing as 2 times 1, which equals 2. And then I'm simply going to divide. Okay, so we would have 12 for my permutations divided by 2. It's going to equal 6. And we can see over here that works. There are 6 groupings of 2. But this isn't how it's always going to work. It's usually going to be a little bit more complicated. I'm going to just draw a line right here. Let's say, for example, we had 6 kids. And we wanted to split them into groups of 3. Now, if we were doing that, it's definitely going to take a lot more math and a lot more just thinking to write them all out. It's going to take a long time. So we're just going to use our permutations that we were talking about before. my first person I'm going to choose in a group, I have 6 kids to choose from, so I'm going to start with 6. Then I've chosen 1 kid, I'm left with 5 left to choose from, so then I chose my 5th. And then the third is going to be, we have 4 to choose from there. Okay, so 6 times 5 gives us 30, 30 times 4 equals 120. So there's 120 different ways I could arrange 6 kids in groups of 3, if order mattered. However, I'm just making groups of 3. So if I have, A, B, and C, that's the same thing as A, C, and B. So to cancel this out, rather than drawing them crossing, I'm going to find the factorial of the smaller set, how many things I chose. So I was choosing them to be in groups of 3. So I was really choosing 3 things there, choosing 3 kids. So I'm going to do 3 factorial, which equals 3 times 2 times 1, which equals 6. And then my third step is I'm going to divide those two numbers. 120 divided by 6, and that will give me 20 combinations that I could come up with, 20 unique combinations of groups of 3 out of 6 different kids. Okay, so we're saying again, this is using combinations. Order doesn't matter following these steps. Okay, I'm going to give another example problem. Okay, so this is a little bit bigger one. We have 8 ice cream toppings. So you go to the store, 8 things to choose from. You can choose 6 of them. So that's a lot that you can actually choose. You want to figure out how many different combinations you can make. Again, order doesn't matter. If you do sprinkles and then a cherry, it's the same thing as getting the cherry and then the sprinkles. You're just picking 6 combinations. Sorry, just going to straighten that. And so we could see right here, we're going to start with thinking the math that we would do here. You can 8 toppings, I can choose 6. So for my first choice, I have 8 things to choose from. Then I have 7, 6, 5, 4, I have 1, 2, 3, 4. I've chosen 5. I still have 1 topping left times 3. So I could get out my calculator and I could figure that out. Okay. I'm going to show you a little trick though to go a little faster. And then I'm going to also find my second number, which is the factorial of how many choices I made, or how many things are in the smaller set. So in this set we had 6 things that we picked, 6 toppings. So I'm going to have to divide this by 6 factorial. Okay, which equals 6 times 5 times 4 times 3 times 2 times 1. Okay, so I could get, so I'm just going to get my calculator here. Remember, you can use your calculator. Often above the 3, there's a little exclamation point, so I could do 6, push the shift button, push that, and that would tell me that that is 720. Okay, I could do the math for the top one, 8 times 7 times 6 times 5 times 4 times 3. Again, it's fine if you're using a calculator for this. I just want you to write down what you're doing. Okay, so you don't have to multiply these by hand. 20,160. So I could do 20,160 divided by 720. Right? And I got 28 for that. 20,160 divided by 720 equals 28. Okay. Now there's a little trick that you can hear, 28 combinations. The little trick that we can do is we can think about what numbers we're really dividing. Okay. Now I'm dividing this set of multiplied numbers by this set of multiplied numbers. Okay, or 8 times 7 times 6 times 5 times 4 times 3 divided by 6 times 5 times 4 times 3 times 2 times 1. So if you want to make your life a little easier, you can just look at, okay, well if I'm multiplying by 3 and dividing by 3, those are really going to cancel each other out. If I have 4 on the top and on the bottom, I can cancel those out. And I'm left with simply 8 times 7, which is 56 on top, divided by 2 times 1, which is 2, which is also going to give me 28. Okay, and that's just a little bit of a faster way, especially if you're working with really big numbers. If you don't have a calculator or you just like to go a little bit quicker through math, that's definitely a method you can do. So remember, when you're doing combinations, order doesn't matter. So you're always going to have less possible outcomes than if order did matter. Okay, if order does matter, you always have a lot more. Hopefully that'll help you out, and good luck with it.